people are actually going.
Yeah.
Okay, I think we're good. Let's go ahead and get started. This is Brandon Moore. He's a Mesos, the meetup coordinator for Mesos, which meets here every few months, kind of deal. Dev and I are both Mesonauts, and basically Mesos is an outgrowth of some technology that's been growing for the last about 8 years, 10 years, not commercially, but open source wise, being used at Twitter is one of the big use cases today. And I think you guys really should be interested in this for data centers, for efficient use of hardware. And that's the bottom line of what this is.
Right.
Much more efficient use than you get in today in the big data world.
Oh yeah, definitely. Thank you, everyone. First off, I apologize. There are plenty more professional-looking pictures than I have right now. I've been trying to get here since Friday. I was in Silicon Valley, left there Friday night. My flight got canceled. I had a layover in LA. I didn't get there till yesterday morning. I had an event to go to in LA. I stayed there for a day. I took basically a red eye to kind of get here, but then there were delays with that. So I am wired right now. I drove in from the airport, and today is my first Father's Day. I have a 5-month-old daughter at home. So, yeah. Yeah. All right. So, my company the company that I have is, we do consulting in the big data area. I've had experience with local startups. I helped IBM start their cloud and analytics business. And from that, they let me take some of my intellectual property. And so, I've focused on this sort of area around big data that no one's looking at. It is literally the 90% of the iceberg is below the water. It's the infrastructure. Okay? It's the infrastructure. And you as application folks, it becomes more important that as you begin to make yourself aware of these things, this will be potentially a very large opportunity in any organization that you work in to truly understand different ways infrastructure can be employed. So I run the local Mesos users group here, and it's called Metroplex Mesos Groups. So everyone who joins as a Mesonaut and Al and Dev are a part of that particular group. Okay. So you go out to meetup.com, take a look. We meet here, and what we do is we do a very good job of coordinating with the other groups that have additional technology that's adjacent to it. Because what you're going to find here is that everything that you learned this week totally applies to what's going on here. So let's get into it. I'm not going to keep you here forever, because I want to leave time for discussion and understanding of what this stuff is. And yes, I bought this t-shirt yesterday because I ran out of time. So, 1996, the reason why I bring this to point, I started building websites in 1994, okay? And in 1996, at that particular time, a couple of key technologies came into place that really sort of pushed the adoption of the World Wide Web, okay? And so as a result, it's not 2001 when VMware really started to take off. They had their own sort of revolution itself, but I really feel like Apache Mesos will have a much larger effect upon computing as a whole. More like the World Wide Web in 96 as opposed to virtualization in 2001. Does that make sense? All right. So, okay, we need some context. Cloud computing is the most hyped buzzword in all of everything, and now it's been replaced by Internet of Things, which has then been Internet of Everything. Google created the term, and I'm telling you right now, anything that they write a paper about or that they open source, it's 3 generations old. So they're laughing at anyone who even thinks about cloud computing because they've been doing it longer, better than anyone else. And so as a result, you've had other people try to do things similar. Clustering, putting different machines together. But typically the problem's been with these types of systems, it required homogeneous hardware. The hardware had to be exactly the same. And then on top of that, you had software that tried to tie these resources together. And some people then tried to do it within systems with things like NUMA and other sorts of clustering things. But guess what? It was only one purpose. For the most part, you had the people who had money, HPC folks building these types of systems. But it was getting clear that in the commercial space, in the regular enterprise, this type of computing was needed. So, Google changed anything. They changed everything. Why? Because at the scale that they were deploying their application, they outstripped the supply chain of any particular vendor that will sell the system. That's how big they are. They are so big that they have direct relationships with the manufacturers. They source the components directly. They build their own systems. Facebook does the same thing as well, and many more of the web scale companies are moving in this particular direction. And so, for those of you who know a bit of the history, I won't get into it, but it kind of looks like Genesis for you, begat, much begat, Hadoop, which begat. Either way, we have Mesos, and it came from Google writing a paper about Omega, which is a system that they use to manage their infrastructure. So what happened, this paper is written. Everybody familiar with AmpLab? AmpLab, Berkeley, applications, people is P, and A is algorithms, machines, and people. So what the folks did there, specifically a gentleman named Ben Hyman, who was working on his PhD in clustering. Really, it was more like multi-core processor clustering stuff, again, trying to figure out how to get more out of a single image, right, because of the issues with distributed computing. He took that paper, and the guys at Berkeley said, you know what? We're going to create something called Mesos. And so in the whole scheme of things, I'm sure you've seen a lot of these this week, but Mesos sits at the bottom of all these things that you've either heard about, you learned about this weekend, what have you. It's the layer that all of this stuff can run on. So you're probably thinking to yourself, thoughts about this virtualization, right? So we just kind of went through this. And so what Mesos does, Mesos then became a top-level Apache product. What a Mesos simply allows you to do is to give you all these things that people were looking for in terms of grid computing, clusters, and whatnot, but you don't have to have the same type of hardware for each individual underlying hardware system, right? So that takes expense out of the way. It's multi-purpose. You can run Hadoop over the top of this. You can run MPI, for those of you who did any mainframe, not mainframe, but high-performance computing programming before, Spark. Really, anything that's a Linux-based application can run over the top of Mesos. You have total complete freedom to build your own frameworks. Even if you have your own applications, you have the ability to build applications over the top. So you're probably thinking, okay, Brandon, that sounds cool. Scalability to 10,000s of nodes. Well, yeah, this is what Google runs on. It's not the exact, God bless you, it's not the exact version, but it's how they do what they do. And it's available for Linux, all these different things is available for very many more.
Yeah, and you didn't talk about who uses Mesos
Forgive me.
for that. Okay.
I'm just blowing through it because I just want to expose this to you, okay? I feel it's interesting enough that after you hear about it, because people are probably looking up online now, it's interesting enough that you're going to be drawn to it. So we'll keep from there. So again, arguments for running a data center, there are all these different things associated with that. I won't spend too much time here. But here's the whole idea. Prior data centers, everything was statically partitioned. You created a box, right? Whether it's a virtual machine that's a box inside of a box, or whether you created a bunch of boxes to run a particular application, right? What Mesos does is it takes every single one of your physical servers and turns it into one single computer image. And at that particular point, it looks like one very large computer. For those of you who are cluster type folks, it's basically the ultimate M+1 cluster, right? If one machine goes out, the whole virtual computer image doesn't go away. It just loses whatever capacity of the physical machine that dropped out of the cluster. If there was work being put on it, it moves it somewhere else. It doesn't matter what the job is. The other thing that this does, right, as we see here an example of what it looks more or less like, Hadoop, Spark, Storm, Cassandra, Spark, Hadoop can run over the top of it. Essentially what Mesos does is that not only can you run these individual applications for them, but you can run them as if they were data center level services. So that when you build an application on top of it as well, you can just simply call these services and use them as you need them, as opposed to going through the process of installing things to your virtual machine, or you got to install your own instance of this. The concept of silos, both from a physical sense, but also in the application space, in a lot of ways gets obliterated. Because now you just think about, it's one big machine. I need resources to run what it is. I need resources to run my instance or my particular set of jobs. And that's it. What's even better, and this is what the guys who manage the infrastructure like, once you are done with those resources, guess what? The data is saved, and your application is no longer running on the infrastructure, at least not in a way where it's consuming unnecessary resources like, say, virtualization and virtual machines do today. What it also does at a large system level is before, instead of having dedicated, statically partitioned places you're going to run, say Ruby on Rails or Memcached or Hadoop, across the entire system, you can run these elastically. And as their demand for resources goes up and down, the system can address that as a whole. And so at no individual point is the machine ever underutilized. It can be fully utilized, yes.
In the last 2 days, we have been hearing about distributed computing. You are talking about cluster computing. Is it synonymous?
Well, I'm talking about both of those and even more. It's more than distributed computing. See, that's the thing. When people ask what Mesos is, depending on your background, I have to use certain terms to bring you into it, but it's distributed and clustered computing with resource management across heterogeneous systems. Clustering, you have the same type of system everywhere, right? And typically it's single purpose. Distributed computing, usually it's just at the software level and you're able to distribute work across multiple machines and such. What this does is it combines, it basically gives you the best of both of those worlds. In addition to that, it can provide data center level services for applications that you would normally have to run by yourself. What it also provides to you is direct API integration with whatever particular language you like to use to do what so many companies are trying to sell today, software-defined data center. This is more software-defined data center than anything else. You can use Scala, you can use Python, you can use Java to say, Mesos, I want you to go run this, this, and this for me. You as a developer can say, I need these level of resources, go run this, this, and this for me. Save the data here and give me, save the data here, tell me when you're done.
So when you meant heterogeneous, it could be different OSs, different levels of flavors.
So, heterogeneous in terms of the physical hardware, which is usually most of the issue. You could have it running on different versions of Linux, but I would say to you, But, so heterogeneous can be Linux, it can be virtual machines, it can be the cloud, all at the same time. So think of it in that sense. Now, from a management perspective, you run it inside of your data center. Having the same OS everywhere up under this would be advantageous, but the cool thing about that, because Mesos runs as a process on that Linux machine, it does not have to. It's just when you start applying the rules of a data center and an enterprise, and those other things, folks are going to say, hey, look, I want it all to be the same, or this is what we specialize in, this is what we manage. But at the management level, you don't even have to interact with the system administrators anymore to install the right version of Java and all these other sorts of things. You just need a Linux operating system, Mesos code. That system is added into the cluster, and you get all that wonderfulness up above that. Did I answer your question?
Yeah, and it kind of sounds kind of how the hyper-converged infrastructure is coming. You've heard of Nutanix?
Yes.
They are threatening vBlock. It's kind of what you're saying, but not like, in a way it's like what you're doing, but it's not totally.
So that's great that you brought that up, because I was a part of the team that helped define what IBM's Pure Systems was going to be, as well as how it was going to be from a cloud perspective. And we talked with Nutanix. I can talk about it now because all my statute of limitations doesn't matter. Right. We talked to them very early on, so I'm very familiar with what Nutanix is doing. Their focus, however, is more towards the hyperconvergence of the infrastructure itself. But what happens is that the way that they're doing things, it still causes limitations in terms of being inside of that box. What this does is it says you don't need all that Nutanix stuff. You can put a stack of whatever together. It can be anything. We could link all of our laptops here together into a Mesos cluster now within 15, 20 minutes and be running stuff. And we would look like all of our machines were united as one. And then each one of you could run your own individual things on that virtual computer image, yes.
But I thought you just said that we could be heterogeneous, but cannot be on different OSs. So we are on different OSs possibly.
Right. It's to demonstrate the idea, right? So yes, you can do it. But those of us who work in companies where they have a production data center, the production data center guys are going to say, I don't want to do that from a management perspective. But can you do it? Sure. Definitely. I mean, if you can run part of the Mesos cluster on your box, but then there's another piece of it that lives out in a cloud, pick your cloud provider, Amazon, MetaCloud, DigitalOcean, whomever, you can extend your Mesos cluster out to a cloud as well. So yes, it's the software that makes the linkage, okay? So yes, heterogeneous all up and down it, okay? Within Mesos, they have this concept of frameworks. So really it's just applications, but it's applications that can be installed at the Mesos level and made available to everyone there. All this stuff, most of this stuff, if you hadn't seen it before, half of it you've seen this weekend, but yeah, all this stuff already runs already. And because of the way this kind of works, they constantly add machines to it. Cassandra's in here, see? And each of those are color-coded by data storage, batch scheduling, what have you. All right? Any questions thus far? Yes?
It's like a centralized monitoring on one machine. We can have the control of all systems and we can do restart, start, or we can, it's like more on monitoring, right? It's like
so look at it. So the quick answer is yes. You have a web page that shows you what tasks and processes are running. And they can, in most cases, if one fails, it will automatically restart. Obviously, you can tell it to email you and come back and say you need to restart this. But the whole idea is if you started a task, you want that task to complete unless there's some certain type of error. It will complete. It will restart what was necessary in terms of lost resources in order for it to finish.
so it will support like the starting of applications, different applications running on different systems.
Yes. So look, but also, yes. And then also what this drives, for those of you who do build applications, the concept of building out microservices. We've been talking about this idea of having, a database that I can, when I'm building an app, when I'm building my Enter app, all these different things I want to compose, make the components of, being able to say, just call the database, just call the application server, just call the web server, and build the app using microservices and components, as opposed to I got to install this and configure this, I got to install that, configure this, I got to install this and configure this. Okay, now I can start my application work. Now it's just a part of the system is available. You don't have to worry about the known constraints of there not being enough database space or not being enough application space. You just go out there and say, hey, this is what I want. Is it available? Yes? Let's go.
In the normal architecture, I'm going to call it traditional. You have your physical servers. They're not, most of them are hooked to your SAN, and these are connected to the traditional fiber optic channels or whatever, the switches and all. That would still continue to stay because that's where Nutanix is addressing it. In Mesos, would that underlying architecture still continue to stay where physical servers, your switches between the servers and the SAN?
It could, but the answer, yes, because Mesos runs over the top of that, and it would just recognize all of those individual resources as a part of the overall image. So it doesn't care what's below it from a physical sense. It just knows when this server is given to me, I know it has this much RAM, this much CPU space, this much storage. And for every other machine it says, Mesos will aggregate those resources together. And the way that it's built out is it has the scheduler separate, the init is separate, and they're able to schedule the resources across those physical machines. It's the Mesos slave that runs on each, so there's a master-slave relationship for each one of them. There are slave processes that will run on each physical machine that reports up to the ultimate cluster, and work is distributed across the physical machine. So as you're running, say, any one of these, at the Mesos level, you're just running a Hadoop job with 16 processors, however much RAM and however much space you need. Down here, you're going to have physical machines running individual pieces of that based upon how Mesos decides, or you can decide that as well.
So help me out here. I want to make sure I caught this. If you had a 100-node Hadoop cluster,
Right.
if you had a 100-node Hadoop cluster, and you defined everyone to be the size of a physical machine that you happen to have down below it, you know, a dual socket quad core, pick whatever, you know, 100 gigabytes of RAM, pick them, and fiber channel connectivity and all the standard data center connectivity. You would lay Mesos on top of that. You would have an OS on that physical machine that basically hosted Mesos
Right.
and hosted your application, but Mesos would basically take, what did I say, 100 nodes, allocate them to this Hadoop job, if you will, or Hadoop cluster, and then, you know, basically stand that up along with the name nodes and all the rest of the crap that you needed to fire the thing up, and then you could run the jobs, and it could either take it back down or, okay.
So it's
How
elastic
far
on
off am I?
demand.
Hold on.
Is that what you're?
So not
I'm
not
right.
exactly.
I'm not right.
Right, he's not right. So you can take, so let's start with the beginning. You can take your 100 node Hadoop cluster that you built now, that's currently a silo of compute power in the data center.
Does everybody buy that? When you stand up a Hadoop cluster, do you take 100 machines and say, that's Hadoop? What do? You've got to assign, you've got to build your Hadoop, and I'm going to build a 100 node cluster, so there's 100 machines. Chunk. You
What's
slice
your-
that off of whatever, and you start installing OSs and Hadoop and all that crap on it, right?
Right.
Say yes. I want to hear him say
You're,
yes.
you're saying virtual or
Well, virtual,
Doesn't matter.
or I head towards physical on Hadoop because I don't like
and I
that.
don't know Hadoop, so I'm going to use for the general entire architecture as virtual.
Okay, it's virtual. So you're going to pick, in my example, I had dual socket quad core machines, so, and therefore that's the size of a server, so you're going to stand up that or some little bit smaller, however you decide to do that. But you're going to need 100 nodes to do that. Are you going to run anything else except Hadoop on those 100 nodes?
No.
Okay, that's where he's going to start talking.
Right. What Hadoop does, even after you've stood up the what Mesos would do, you've stood up the 100 node cluster. You can install Mesos on each one of those 100 machines. And then what it does is it just says, yeah, I see Hadoop running there, but these resources are available for me to use. I can then not only I can basically run everything that's above Mesos on that same physical infrastructure. So now you go from a silo of compute power that's been dedicated to run this one simple thing. You can take any of those Hadoop jobs you've run below, you can run them in Mesos. And the way that you run them is simply by telling it. It's a declarative sort of way of saying, instead of statically provisioning a 100 node Hadoop cluster, I can now combine that 100 node Hadoop cluster together and then say, all right, now I can submit a job to Mesos and say, I need to do X. If you want it to be 100 nodes and whatever that is, Mesos will give it to you. And then when that job is done, instead of it sitting there running, the job is done. It writes its data out to HDFS in this particular case, and it goes away.
Yeah, and when you say job is done, you control whether the job meaning those MR jobs.
Right, MR
or
jobs.
the job being Hadoop. Okay, so don't think of it just goes up and down every time you start an MR. You could, but it doesn't necessarily. The question I think he's going to head towards, I'm going to ask his question for
Sure.
you here, is you've got these 100 nodes of Hadoop running, and we're going to, I've got a cluster, I've got a machine of 1,000, or a data center with 1,000 physical servers in it, but I've got 100 sliced off for Hadoop. And it's in a Mesos cluster now, rather than just a standard filled Hadoop, or virtual Hadoop, I don't care. Those CPU, let me be specific, CPU resources that are assigned to that Hadoop cluster, that Hadoop machine, or part of the cluster, are those resources, CPUs, dedicated, reserved, guaranteed
Static
for that Hadoop job?
And so, yes, if you've got 1,000 machines in the data center, you've carved out 100 just for Hadoop, it's only available for Hadoop use.
Okay, now let's talk Mesos
Right.
in that same case.
So now what you can do, even with the other things running, production guys may not like it, but conceptually, you could install Mesos on all 1,000 machines in the data center, and then have that available to run Hadoop jobs, Spark jobs, MySQL, what have you.
I guess the question I got, I'm sorry.
That's fine.
Here.
This is good because we may not get too much further past this.
But if I build a virtual machine and take up a server and I install Hadoop on it, how does Mesos know to use that server, those CPU cycles for something else? Or does it use those CPU cycles for something else? Have I, in effect, because I sized it that way, that is still, in effect, reserved? Or can I run other jobs on that same physical node?
Yes, you can. I mean, the thing is that Mesos is a well-behaved process that runs on a Linux workstation, right? What's available versus what is used, what happens is that, sure, you've got all those resources available on that individual box. If there's other stuff running on it, when Mesos as a cluster goes and requests resources to run its job, that one physical node may only have so much to give, because once the Mesos slave process says, well, there's really only two, this is a 16 processor box, but there's really only 2, maybe 4 processors available, I can only give you 2. So then the Mesos cluster says, all right, I'll go to the next Mesos slave. What do you have? Because somebody made a request for 16 CPUs to Mesos, I'm going to go out and find where those resources are, combine them together to satisfy that resource request. So it's not going to do like, it's going to do intelligent checking of what's there, right?
It's a dynamic provisioning on the fly.
Exactly.
But actually, we're just moving from the traditional architecture to Nutanix, so it's kind of spinning boards with me. Nutanix also kind of does this, but Nutanix, well, what it does is the traditional read and write with virtual to the storage to the SAN, it's a lot more effort. So they take that, they call it the hot area, something like that.
Yep.
They write it over there, and then there's a virtual manager that's constantly, something like an hypervisor, that's checking, how is the throttle, it checks all the throttling and all.
Right.
Even that kind of,
Is Nutanix an operating system?
no,
or is
Nutanix is a hyper-converged infrastructure, it's not
Right.
OS. It's, so think of, if you want to provision a modern architecture, you have physical, you have virtual, then you have switch, then Ethernet, and then SAN. But all this in the traditional architecture, that there is high latency, and if there is any bottleneck, it's a nightmare. Nutanix, vBlock?
No.
Basically, now everybody is talking of converged infrastructure.
Yeah,
So-
it's the idea that the companies who are selling computers to make money are putting everything together and selling it to you as a complete sort of block. And you can get those flavored different ways. It can be a VMware flavored one, or you can go with a vendor like Nutanix that has created their own way of managing all that together so that you have a single interface to the management of the box. What's happened is that none of those guys have moved up into the application space, which is what other vendors are trying to prevent them to do, but then none of them have moved into that space for big data applications, because big data applications right now, in the traditional sense, require dedicated hardware. What this does is a lot of the things that Nutanix does in that converged infrastructure, you really don't need. This can strip you all the way back down to just getting really big single servers without any SANs. You can use direct attached storage. That's one of the ways of deploying it.
So you ask me something, when you say Hadoop, who are you referring here as Hadoop? We didn't hear that from, I'm trying to understand the 3 flavors of Hadoop. Who is currently supporting Mesos?
So there's 3 distributions of Hadoop.
Right.
Okay. 3 major ones: MapR, Hortonworks, and the other one,
Cloudera.
Cloudera. Okay. 3 distributions of Hadoop. All right. First of all, you can run all 3 of those in a native form on top of Mesos. So in reference to that, there's a company called Mesosphere. Mesosphere is the company that has taken much like you take any open source stuff, and they built services and such around it. Now what Mesosphere has done is they've taken it a step further and provided you an interface to see how all of that looks. What's important to realize is right now they're the only ones that have done that. The basics for the Mesos functionality that I'm talking about are all still very open source. Really the only thing that Mesosphere has done is they've contributed a lot of OS codes. They built a very, very nice interface, and they have consulting and other things, but it's centered around their distribution of Mesos. So Mesosphere is the only company that's like, Mesosphere is the Cloudera, MapR, Hortonworks of Mesos. So right now, that's the one, and then I'm doing it too, but anyway, I'm gonna talk about that. Yes.
Alright, so the way I understand it is that you're saying that if my 100 nodes are dedicated towards Hadoop,
Mm-hmm.
obviously at any instant, all 100 are not being utilized.
Correct.
So that idle time where my resources are sitting, this guy can help me find which one is sitting and not utilizing any resources and take that time and then start running the job.
Correct.
And let's say if I issue the job to Mesos and, well, lo and behold, all 100 are being utilized right now to a certain extent, then it's going to sit in a queue and wait until it gets a response from one of them.
Yes and no. It depends on. It can be configured to operate that way or not. Typically, when you run your jobs on Hadoop, right? The jobs themselves, you size it at 100 nodes for a particular reason, right? Okay. So what happens there in Hadoop, once you say, hey, I need to run it, you just say run this job, and it takes up whatever. What Mesos allows you to do is once you understand your jobs a little bit better, and you say, well, really, it's only using this much of this 100 node cluster. Okay, I can just ask for that much. And what Mesos does, it gives you the exact resources you ask for, and then if it's 16 nodes that you need, the other 84 are still available to accept something else, or do any one of these other things that are on the board, on the screen at the same time.
So I need to tell Mesos that which
Right.
of the nodes out of the 100, maybe the 4 of them or 8 of them
No,
can be
you
utilized.
just say Mesos, here's how much I need in terms of CPU, RAM, or whatever to run this job. That's it. Mesos goes out and finds out where everything is, and then runs the job for you. And then when it's done, it tells you it's over and comes back. As opposed to in Hadoop, you just say run the job.
Yeah.
You don't get to specify how much in terms of resources you need. I need to
So
get back.
it will take control of OS. Like OS is already having its own kernel and its own methods of managing the system.
Mhm.
So it will override that one and it takes control of the kernel as well.
So this is where Mesos is like distributed computing. Mesos is a piece of software that runs on that OS. So just like any other process running on your OS, it's going to have the ability to see what is being used, what is not being used. Okay? So yes, it has its own stuff. What you just talked about, it has its own stuff going on. All Mesos does is looks at what's available in that individual machine and contributes it to the cloud. It has the potential of using all of it if all of it is available, right?
But system should allow, right? Like there are two systems. I'm not talking about Hadoop. In general, if you take any Linux system or Windows system, it has its own OS, and we have two systems like that. So if you are trying to utilize the other system's resource, that OS should allow. Like, I mean, it means like somehow we are taking control of that machine's
So-
kernel or whatever.
The question is, does Mesos take control of all of the machine's resources? No. It makes requests to the underlying OS, can I have this much resource, as a process that's running on the box. In response to a job that was submitted to Mesos of a certain size.
Is this more catered to a big data market or can it be applied for a regular enterprise?
So my answer, yes. I mean, look at all that stuff up there. There's stuff up there that's not all big data. I mean, if you got any Linux app, now right now it's Linux only, but if you got anything that runs on Linux, can run on this.
I have a basic question about job tracker.
Yes.
So where does the job tracker run? On the Mesos machine or is it on the...
So you have Mesos, Kronos, and Marathon are frameworks that do job tracking for you. That's why the graphic is set up in this particular way. And so Kronos is more like cron in terms of it manages things as a task that are submitted, done, and then brought back. Marathon can run them as well, but Marathon is more suited to long-running tasks as opposed long-running applications. It's separate from Mesos itself. Mesos is the coordinator of those resources in the working piece. Kronos and Marathon help push work to it, right? Think of Marathon as the init system on Linux. think of Kronos as the cron system on a Linux operating system.
So,
Go ahead.
So basically, normal Hadoop clustering, job tracker takes care of which machine I have to assign this job to them.
Yeah.
Right.
Scheduler is out of Hadoop to this guy, Mesos.
Right. So what happens? So
So
even
what
better.
does job tracker do in this case? In this scenario?
So from a Hadoop perspective, from a Hadoop perspective, Hadoop can run as a service within Mesos. And all it does is when you submit your job to Hadoop, Hadoop, using the Mesos framework, will coordinate with Mesos to say what resources are available to run it.
yeah, but you still got the name node running.
Yes, the
Just
name
happens-
node is still running. Thank you, Al. So Hadoop in this case runs as a service inside of Hadoop. Like you can configure Mesos, and when you go, you can say Mesos install Hadoop. So now Hadoop is available as a service in Mesos. So now you just say Mesos, I want to run this Hadoop job, I want to run this Hadoop job, and then it says Mesos, your framework working now, go and do it.
No, but to answer your question, Mesos.
And when you install Hadoop as a service in Mesos, you've got the job tracker, the name node, all the infrastructure is already running when you start the service itself.
Including
Yeah,
the
but,
local
but,
disk.
but what I learned from Hadoop clustering is job tracker takes care of the load balancing, finding the resources.
So that's what you're delegating it to Mesos.
Why Mesos again?
No, you're making, okay.
Because-
You're missing the point. So now he's saying, okay, I have an architecture here where regardless of what that application is, Hadoop or Spark or whatever you write, let me take care of the scheduling across what the machine says. When he says, I got 100 node Hadoop machines, you're really running 100 Mesos in each of these boxes. I mean, each one of those boxes are running Mesos. Right? You think of a mission, in this case, a 1:1, right? You're running Mesos on each of your machines. That's how
And you're running Mesos just to manage the local machine, but and to coordinate what jobs run on that local machine. But you've got this larger Mesos thing that is scheduling and telling
Right.
you, machine, do that job.
Right. So,
And on that machine also, obviously, is
So,
MapReduce.
For me, just on the same thing, you know, when you do the cluster, you define your nodes, whether it's a physical IP or a virtual IP. When you abstract, already, you know, with virtualization, you abstracted physical. Now, this is a virtualization on top of that virtual.
So no, it's not. Because now, so here's the other piece that we've got to remember. What happens is that Mesos has made all those individual machines look like one now.
Yeah.
Okay, so it looks like one in each one of those processes. The translation between how the Hadoop framework works with Mesos takes care of all those individual pieces of the application you need to work. From an application perspective, it's not going to look any different to you or anyone else using it. Below it is where it handles all these different things. The other way to look at this in the respect of time is you look at who's running this stuff. Okay. Mesos is the reason that Twitter doesn't go down anymore. Okay. I can forward through. These are all the ones that are publicly known users of this stuff
In production.
in production. Ben Hyman, who created Mesos, went to Twitter and he helped stop them going down. This is a way to run a data center so that stuff doesn't go down anymore.
I want to ask one question.
Yeah, go ahead.
What's below Mesos? You can run Mesos on in a virtual environment, right?
Mm-hmm.
Is that the optimal solution?
No, but
What is the optimal solution?
the optimal solution is how much money do you have in your pocket? No, hold on. No, seriously, like that.
That's a terrible answer.
That is a terrible answer, but it's true.
To answer you, what do you consider as Mesos? Let me ask you. I'm considering Mesos as an operating system. Is that true or not?
It's yeah.
Data
So
center operating
Mesos
it's-
is an operating system. There's
Data
nothing
center.
underneath it. That's why he's referring to the kernel.
But you don't put that on top of a. You don't
It
put.
is an OS.
I don't think it's an OS, it's command center.
You don't put that on top of a virtual. You put it on a physical.
No, it
Right.
doesn't matter.
Hold on.
Why would you?
So let me clear that up. So you can do both. You can run Mesos in OpenStack. I don't know why in the name of God you would do that, Vishnu, and all the others.
Well, you can do it in VMware.
Right, you can do it in VMware.
Right, that's what it is.
But
It is
why?
an operating
But you
system.
said it's not efficient there.
So it's not efficient. It's not efficient because of the. It's not efficient because of the underlying architecture, right? It's not efficient because you're dealing with the losses associated with virtualization and such. But if you want to run, if you want to run your Amazon, if you've got a bunch of Amazon Web Services images sitting out there and you want to get better utilization of those, Mesos is a great way of doing it, if that's where your computing comes from.
So I'll also add to that, right? So I think people are hung up here and saying, I
Right.
get to see that point. What they're saying is, do I need to have an hypervisor underneath that? Why does it make sense, right? Hypervisor could be in Microsoft or it could be a
Right.
VMware. I'm saying it's an operating system. Now technologies have evolved. You don't need a hypervisor. You can run n number of Mesos on the same box, right? So you can split it up with the Docker or however way you wanted it.
Can you run Mesos
So the
on
virtual
Mesos?
concept goes away.
Yes.
Yes. You can run Mesos on, you can run Docker on Mesos, right? So let me just go to this, because everybody, Docker is another hot word. So you could have Mesos running Docker, and then you could do Mesos inside of that, or you could do Docker virtual machines. You don't need a hypervisor in order to run Mesos. So that's the first thing. You don't need a hypervisor to run Mesos. The second thing is, can you use virtual machines? Yes. Can you? But what all these other things don't do is you can't run a Mesos cluster on physical machines and virtual machines and cloud infrastructure all at the same time. And you can't do that with anything in the market.
And tie it together.
And tie it together as a single virtual operating system. So I probably could have started with that, and everybody would have been like, okay, church, let's go, right? But you get the ability to manage those things across all of those. Docker is a framework that runs on top of Mesos, right next to Hadoop and anything else that I've shown you in prior charts, for those of you who know and love Docker.
I mean, so the whole point of virtualization was to use your resources which were sitting idle anyways. That was the whole point, right? Now, why would you want to have a virtualized box and then again combine it to run resources? That it just doesn't make sense why you started with virtualization in the first place.
Well, virtualization doesn't get you outside of a physical box. So you talk about the resource utilization now, this gets you outside of the box. I hate that pun, but it's a great one.
Yeah.
It's computing outside of the box. Go ahead.
But that's what is exactly knocking virtualization with Nutanix. So I'm still stuck with Nutanix and this guy. Nutanix is, and see, we're just moving from this to Nutanix. This is new to me, but Nutanix is addressing the pain points of virtualization.
Right.
It has to deal with the limits
up on
of.
that though, right? So let's
Right.
have the
This-
silent conversation.
what
But
is
let
that?
him go.
We
It is
should-
a revolution for big data, and they're really hot right now.
Let him go to, but let's have that
Right.
conversation.
We can talk about that because I have an extensive hardware background, and we can talk this through. What this does, what Mesos also does, is if you want to stand up, go ahead, Carl.
All right, so we are still having the conversation where we are debating, right? So can you give a yes or no answer? Is Mesos a process or a Mesos an process? I mean OS.
Okay. The answer to that is Mesos as a whole is an operating system.
There you go. It's not a process you install. You need to build the machine from ground up.
If I go even deeper, Mesos is a distributed kernel, right?
So his point was, hey, I already have some Hadoop running on it. Can I go install Mesos on it? I said no, because
But yes, you can. Yes, you can. Hold on, listen. Yes, you can.
then it will be a virtual machine, right? So
It will, yes. So Mesos slave process will run on that Hadoop node. It's going to report back to the Mesos framework the resources available on that Hadoop node. When you're looking at it from a Mesos perspective, it's an operating system.
Then I need to move my existing Hadoop installation into Mesos.
And that's what I help people do.
Right.
So you're making money basically. You're making a lot of money there. You're virtual on virtual.
No, you need it.
No.
That's the short part. But you can go all the way down.
You can't.
I can convert a Hadoop cluster into a Mesos cluster and give you better utilization and reuse of your resources.
Yes, you can
Try not
run
to-
it in a virtual world, but that is not the optimal place. I can nest virtualizers. Is that a good
Yeah, that's the same.
Yeah, do you want to do that? No.
But basically what it means is you're unplugging your existing
So
infrastructure.
then you're taking
for-
a shortcut. You know, that's
No,
a
no,
shortcut.
no.
If
No, you're
you
not.
want to go
No,
to right
you're not.
implementation, it'll be different.
No, it's not like this, right? So you have the master slave structure, you'll be installing as a agent sort of thing on a Hadoop system.
Well,
Wherever it's
no,
like-
don't think of it that way.
No.
Don't think of it that way. Think of it, I erase ESXi and I put Mesos on it. And Mesos is a data center operating system with a kernel. Okay, I put that on every one of my machines. Now I can install Hadoop, anything on top of those, and I manage the resources externally. I can grow and shrink Hadoop dynamically as
So if the use case is, if I have an existing Hadoop installation up and running,
Right.
how do I introduce Mesos? His answer is, you rip apart the existing Hadoop infrastructure, install Mesos and install it.
No, the first answer is you run Mesos in your virtual world
Right.
and just get Mesos running, and then you start chopping off virtual
Right.
hypervisors.
Yeah, you're
putting-
kind of getting into my methodology of what I do.
So,
But I can start.
so
I can,
basically when you
so
run
I can
Mesos,
start.
put Docker, because if you strip
Yes.
out the
Docker.
because your applications are very specific to in the current environments or in that virtual environment.
All right.
In order to avoid breaking, put a Docker on Mesos.
That's
and
an
start-
Right. So let's back up for a second. So
Time up.
time
Go
out.
on.
So I can seed I can seed a Mesos cluster on anything on your network. I can seed whether it's on Amazon. I can start it at Amazon, for instance. And if I had connectivity in through to your data center, I could grow your Mesos cluster out using whatever resources you have in your data center. Right? And so let's say you've got that 100 node, we got 1,000 machines in your data center. I can install Mesos on one machine. You've got those 100 nodes you got dedicated to Hadoop. As I install Mesos every single place in each one of those thousands of machines, yes, you still have your 100 node Hadoop cluster.
Yeah.
But if you submit jobs to the Mesos cluster, you have the power of 1,000 machines. Right? And then after a while, it's like, well, why would I have just this 100 node cluster here that can only do one thing, and it only does it when I tell it, it only does it when I tell it to do it, right? I would have the power of all the machines,
Right.
right? And what happens is when it's done doing what it's doing, it gives the resources back so that you can run something else on it. So Docker could be running right next to Hadoop. You're running a Hadoop job. You could be running Docker on that same 1,000 node Mesos cluster.
Yeah, I
Let's-
think the missing dot there is in what your connection you after in your example. I install Mesos and 100 machines.
Yeah.
The step there is I go back and modify my Hadoop
Yes.
installation to work on the Mesos.
You're rewiring your
So-
Rewiring the Hadoop.
Yeah.
So actually, no, you don't.
You don't have to
You don't have to rewire it.
No, you do not
The
have to
Hadoop
rewire.
as a scheduler, it already knows what my 100
It
machines
does.
are.
But if I have another instance of Hadoop running on another machine, what are you going to do? You're just going to submit that job to.
Sorry, I think I'm still with you on that one. When you start installing one by one,
Mhm.
you in your cluster, whether you call heartbeat, gossip, or whatever SIP,
Right.
that communication is between those two nodes. Now
Correct.
that, okay, it's not virtual, let's call it physical nodes. It's physical, static, or DNS, whatever it is. When you're removing this guy and starting putting Mesos, now, are you changing your IP?
So here, no, you're not. Here's the other thing. I can take the backup of your name node, put it into the name node at the Hadoop level.
At the top of it.
Hadoop can talk directly to the existing HDFS that you had on those 100 nodes
Okay.
and use it.
Okay.
Again, you guys owe me money for that.
Okay, I think what everybody's getting at is the whole central concept in most of the stuff we're talking about was data locality and to map reduce. So if I've got 1,000 nodes and each one of those nodes had some of the data and I distribute the job, everybody can see that. If I've got one OS layer that has all the resources, your data locality, from what I can assume, is now gone.
No.
That's the problem, right? I say, oh, and plus, when I instantiate my Hadoop job, I have to instantiate my entire HDFS, right? My data set, which was a job. So this appears to me to be very, very transient. I have something I'm going to do. I give it to it. It does it. Then it disappears, and I have my result. But in
You're talking
Hadoop,
about
it's not like that. I've got all this data
Correct.
that always needs to stay there. That's never going to go away or be available for anything else.
So,
He's talking about the direct attached storage to those 100 nodes, not the 1,000 nodes, right? I've got a data
well,
center.
hold on, wait. Stop,
Yes.
stop. Okay, yes. But here's the thing. Mesos can use different data sources. If you got an existing HDFS, right, it can use that and access that, because when you go and set up, put in the information into Mesos for what your Hadoop cluster looked like in terms of those 100, it's going to have all the you're going to be able to put the information that says this is where you go to get this.
Yeah, but no, his point is it's direct attached storage on that node.
Right.
It's not, so you can't just go to any node and see that storage.
Right. If
Okay, so I think the point you're trying to make is well, I want to go a little different.
Right.
How do you've got your 100 nodes of Hadoop, how do you grow that? How do you over time expand that or migrate?
Allocate that node resource
Okay,
from that
that's
local
how you move to
data.
Mesos.
That's
how
a
you
problem.
move.
It's not a fungible resource. They go together.
I understand
if I
that.
try and
I
expose
understand
it
that.
broadly,
Completely direct attached storage. Got it. So how do you add a node to Hadoop? You do that with Mesos, and now it's a Mesos Hadoop node. Now, how do you subtract a node from Hadoop? You do that, and it's gone. Okay.
Okay, so you tell me,
Well-
Mesos, I still don't get it, because Mesos has to know that this data is here
Yes.
Correct.
in order to distribute a job for any effective.
That's right.
Well,
Function.
okay, right. So it has to know where to go to get the data,
Right,
right, which is in HDFS.
right.
Okay. And how do you
And
know?
so
how do
it
you-
knows HDFS. It says I'm going to stand up a Hadoop node instance here because it's attached to
Right.
that.
So we got data nodes, right, which are running HDFS.
Yeah.
We got name node, job trackers, and we have nodes that are just running jobs. Okay? That's where the separation is. Within Hadoop, you can run more of the job nodes. The data nodes, you're not running anymore. In this particular case, where you're going from the 100 to the 1,000, you're not adding any more you're not adding any more data nodes at this point. If you want to, you can.
What's your standard add data node?
Right.
You're replicating.
The data nodes and what does the compute, it's separate within Hadoop. It was built to be that particular way.
Well,
So just this discussion definitely needs to be talked about in depth. Maybe it'll be the next subject for when we have our Mesos group. But my answer to you is DFS, the data nodes are separate. That's a separate instantation of data. That's where everything is. Mesos has the ability to talk directly to that. You don't have to add any more data nodes. What Mesos does is for when you have your jobs that are running, and then it goes to the name node, it gets the information, the name node says the data is here. That's what it's doing. It just allows you to run more jobs. It doesn't, unless you add more data nodes to your DFS, it doesn't manage HDFS. Let's start there. It doesn't manage HDFS.
so
Okay,
so
that's
the,
what I didn't get.
Right,
Once
it
you
doesn't-
extract that
Right.
those disk resources into it, you've
Right.
lost everything.
No, I think his point is, I think I got your point, is that Mesos understands persistent data in a HDFS, for example, in an HDFS, and it knows where that's at. Okay, and it won't just say reallocate that storage to something else. It's a persistent thing. So you can go up and down on processing, but I don't understand how the processing, I always thought the processing was on the same node with the data node. That was the whole purpose. So
No, the processing, the
which
compute.
processing? MapReduce.
There's the two sides of it. Listen. This is what I will do. This is what I will do. I will answer this question.
And I'll shut up.
No, I will answer this question just simply by saying Mesos doesn't manage HDFS if you don't want it to. Okay. There's the map reduce side that works on the HDFS stuff. If you want to have Mesos manage data nodes, you can. But when you first start out, you're probably not going to do that.
Oh.
Okay. Just when you first start, you're probably not going to do that. Okay. But if you add a node, but you can add a data node that's managed by Mesos, you can have sort of the split thing going on because it's all software. But just I'll answer that, not right now.
Yeah, let's move on. I think people are hung up on the use cases. Let's
I
move
have,
on.
I have one more question.
Sure.
No questions. No questions. Let's move on.
I think everybody has.
It's not a question, it's a clarification.
That's a good way.
I have 100 node system.
Yep.
When I added Mesos,
Mesos.
when I added Mesos, it became 1000 cluster, okay? 1000 node cluster. How? So
No,
you
he's taking everything, all the physical
Yeah.
blocks.
It's an overlay.
Yeah.
It's
So
an
is the
overlay, it's an
replication factor is applied to 100 node or 1000 node?
There is no 1000, right? Here 100 nodes
No, no,
only,
no.
and on it we are installing.
100 was dedicated to that Hadoop, but then now he's expanding all his servers.
My replication, is it going
That
across 1000?
depends on the program, right? It's 100, right?
That's
It
still
can be
factors.
Cassandra,
The
maybe.
replication factor would still be whatever you.
No, my thing saying that those replication 3 means we have 3 copies across 100 or 3 copies across
Okay.
1000.
The thing here is that HDFS can stand by itself without Hadoop. Let's just start there. Like if I wanted to build an application to use HDFS to store things without Hadoop, I can do that.
Right.
Okay. So, HDFS handles the 3x1. It handles all the copying and replicating. It does all that by itself. Okay?
Right.
That system, it can be managed by Mesos. It does not have to be managed by Mesos. It depends on where you are. Okay? So, you can make your HDFS as long as you want. So, would you have, say, HDFS running on the same machine as a Mesos slave? Probably, if that's what you want to use as your distributed file system. But you could also use other distributed file systems to store other types of data, but those have to be managed by Mesos. See the difference? When everything's managed by Mesos, you can use multiple different types of data stores to get information from, and then you're able to see things across the entire Mesos cluster. As opposed to when it's all sitting in HDFS, only things that are written to CHDFS can actually use it. You're separating the application and where it runs from the physical infrastructure with Mesos so that they can be managed separately without having to care about what the application people need or concerned with. It's like putting coal into a train. You just put infrastructure in it. You just put it in. The more you put in, the faster it goes. You don't care what the people are doing in the dining cars. If you want to go faster, make it go faster. You don't have to be concerned with different levels of Java and Maven builds and all this other kind. You don't have to be concerned with that. The application folks, which is what you want anyway, right?
And I think where they're hung up, and I'm still hung up in the same thing,
Sure.
is direct attached storage versus SAN attached storage. I'm gonna make sure he's listening to me.
Okay. It doesn't matter.
More later.
Yeah, but it does matter.
It-
Let me start over.
Yeah.
What I think people are hung up on is direct attached storage to a node versus SAN attached storage. We all know the preference for Hadoop clusters is direct attached. I built SAN attached. Yes, I'm stupid, okay?
It's still prevalent.
What now?
The SAN attach is still prevalent.
Right, but the thing...
Not for Hadoop clusters, I
Yeah,
hope.
I mean, not for Hadoop.
Not for Hadoop clusters, I mean, for 1,000 reasons. But your point is, when you do a direct attached storage, and you put all that HDFS data on those direct attached storage, it's not visible to those other guys.
Nope.
Those other 900 nodes out of that 1,000 node thing. It is not. Now, yes, it can be made invisible and all that stuff, but you just killed performance like nobody's tomorrow. So you don't want to do that. You've got to persist it there. It is there. Now you've got to decide what to do, how you use that data. Typically, as I understand it, MapReduce runs on those nodes for the locality reason, data locality reasons. You can't run them on those 900 nodes. Okay, now, that's,
Right.
And until I understand that, nothing you say is really going to make sense to me because I'm just going to be thinking, I don't get it.
Well, the data nodes are what runs the HDFS unless one of those other 900 are made a part of that particular HDFS instance, it wouldn't be able to see the data.
yes.
It couldn't be a data node.
It wouldn't share those. It knows about HDFS. When you put the slave client on, it would say, oh, I see that's HDFS, I won't touch that.
Correct, if it's a non-data node machine.
Well, if it's a data node machine.
No, well, listen, okay. Putting the Mesos slave on a machine, what it does is it makes the Mesos cluster aware of all the resources that are available. Okay.
And yes, if you say, don't touch that HDFS on there, it's not touching that HDFS on there.
Right, you don't have to configure the data, okay. Look, we keep getting back to that.
Because I don't even understand the concept.
Again, my view of it is Hadoop has two pieces: where the data is, where the compute is. The premise of Hadoop was you move the compute to where the data
Exactly.
is. Okay, so since those systems are separate, they're different. They can be separate types of systems.
Right.
You can have the systems that do the computation that are not data nodes, right? They're just not. They're not connected to HDFS. The other 900 machines that are in the data center could be ones that do computation, but they still can only talk to however many data nodes you have available. And what happens is when the job, right, it reads the data off, computation is done, it dumps it back to where the data nodes, the HDFS system.
Right. You're expanding the compute capacity.
Right.
Okay, so what you're saying is the way you would expand an existing Hadoop cluster is to add compute power as you need it, because that's where you that's where you start running out, and then have them access the HDFS through those local data nodes, and then have, in essence, a new Hadoop cluster inside your Mesos, where because you wouldn't keep doing that. The whole point is to have a somewhat standardized deploy for building out.
Correct. So within the 100 nodes, there's compute and data nodes. Okay. That instance passes data back and forth. What Mesos would allow you to do is add more workers, right? You could have more workers, but you would still only have the same amount of data nodes.
Data nodes. HDFS resides within that 100.
Right. Now, the speed of Hadoop is more I/O intensive than anything else because of what MapReduce does within the data nodes. Okay. The value of, say, having data nodes run by something like Mesos is that when one of the data nodes goes away, what happens to your data now? Well, you have another copy of it. That does not go away in terms of Mesos either. It operates the same way. So for you, all we're doing is we're adding the ability to add more workers to a given task without expanding your HDFS. If you want to expand your HDFS, that's great.
That's an extra step.
But that's an extra step. Would you want to put HDFS on the other 900 machines? Depends on if you have the resources to do it so.
So if you have
Yeah, so does it defeat the purpose of Hadoop? Just like you said, data locality, yes, it defeats, but can it run? Yeah, sure, it runs.
Yeah, but it won't affect data locality simply because of how Hadoop works, that all of this stuff gets moved around via IP, the HDFS has an address that you have to go through, the master for Hadoop coordinates, all that stuff gets coordinated and data is passed back and forth using IP. It's a defined resource, a defined spot where the data is. Now, however big your data node HDFS is, That's what's going to determine most of the performance overall within batch jobs and other. Whether that's managed by Mesos or not, it doesn't have to be, but it can be. But the main thing, if you don't change anything, all it does is give you run more trackers, more more workers. In order to increase the performance of the HCFS, you gotta add more nodes. And depending on, and no matter where you add them, you can add them. So, in the case of Mesos, you could add them anywhere else that's available. It may kill your performance, but you can do that. I didn't answer well enough because you got me stone faced here. All right. So there's a Mesos Con. This is the second Mesos Con I am going. It's in Seattle. It'll be a 2-day thing. Right now, Mesos is so small that you'd probably be able to get a selfie with Ben Hyman. Of course, nowadays, getting selfies with anybody is as
Can I
easy as
carry
shaking
your
their
bag?
hands. Go
Can
ahead.
I carry your bag?
Hey.
I want to go.
Trust me, I'm probably going to have to go up one day. So, you know what I didn't show you? Oh, yeah, I talked about that. So we do have a meetup group. I'd like for you guys to come out. We just passed 50 groups. Yeah, 50 people. We'd love to have you. And I can talk about anything related to below this, history, what have you, but this is kind of a long time coming. For those of you who stayed extra, I appreciate you. Thank you so much. But I hope this has been valuable.
Yes.
Certainly has for me.
Okay, I hope this has been valuable.
We can say talk more, whoever wants to talk more, but I really appreciate Brandon. We sort of pulled him in the last minute because, honestly, I believe what Brandon had up there is that your VMware is going away.
I'm trying to be nice, but I'll let him do it.
VMware is going away. Your virtual machine with this OS in it, throw that away. Throw the OS away. You're going to end up with Docker and Mesos, and you're going to be running everything in that environment. You're going to
surprise if you say VMware buying Docker.
Excuse me?
VMware buying Docker.
Well, then there'll be another Docker
There's
come up.
Flocker,
There's
Flocker, there's Rocket, there's
What's the difference between Core OS and the Mesos, you know?
Core OS.
Uh-huh.
Other than it being funded by Andreessen Horowitz, it is one of the operating systems that can run Mesos. It's just another Linux distribution.
It is part of it could be your data
So
center
you're saying
operating
Mesos
center
has got
kernel.
a distribution as well, different distribution?
Mesos is really just an application running on the
Linux.
core OS or whatever OS.
Yeah.
Is that the only OS it can run? Or
No.
Okay.
There's like 5 or 6 OSs.
All the major Linux distributions run it. Mac OS.
Yeah, they also have stripped down Linuxes that
Right,
that
and
can
that's
run.
really what Core OS is. It's stripped down. Everything is updated through the. I mean, it really runs like an antivirus because it's always constantly downloading stuff and
Yeah.
updating.
But the key to me is first off, how fast is a Docker image boot? 10 seconds.
Yeah, milliseconds.
Yeah, compared to how long does a VM boot?
Couple of
Minutes. Okay, now you just got performance where you can stand stuff up and take it down on demand, not have to wait minutes to bring stuff up.
Yeah,
You can
like-
run the same hardware underneath. Yes, data locality and SANs, it doesn't matter. It's just a different OS. And the way you think of it, the way I think of it, is a Docker image and a system that manages those Docker images on demand in seconds resolution and puts them wherever the heck there's space to run those. So you run Docker images that need 2, 4, 6, 8 cores, microservices,
Right.
and it manages, I need 7,000 of them, poof, you got 7,000.
So, because keep in mind, Twitter and all these guys are running Spark, they're running real-time analysis. Literally what they're doing with their Mesos cluster is they're pulling in information as it comes in, right? Spark might be looking at it real time, it gets put into the HDFS. They're running jobs at the same time and things are getting processed, right? It enables a lot of this stuff to happen as a process, industrialization of running their website. All this stuff is sitting together and then it feeds it right back in. I mean, let's think about Amazon and their recommendation system. This will be my last sort of thing. Okay.
Not mine, but his.
But here's the thing. With that, you got people sending data in. While it's coming in, you want to do some analysis of it, right? Then you may want to store that. or you do the analysis, then you send it to something else to process.
Dynamically sized
Right.
analysis.
Dynamically sized. So we're talking about this cloud computing elasticity. This is what gives it to you as demand increases. Forget load balancers at this particular point. You just add another machine, whether you pull it from the physical side or you pull it from a cloud service or from virtual machines. This is getting really Skynet-y here. Think about it every day.
F5 will die then?
But anyway,
Will
What?
F5 die?
I'm sorry, what?
Will F5 die?
F5, no.
well, the thing is, will F5 die? Some people may want it to, but also the idea of, now the network piece, that's where it gets a little interesting, right? Because you still have to network these different things together. But now, if you think about things in terms of what leaf and spine as opposed to regular designs, there's some other designs you can physically do to your network that changes your ability, one, to run this. The networking stuff, it's still a concern, right?
Yeah, it's,
But it's not as much of a concern because you don't have to do as much with the network anymore.
so is that your last one? 'Cause I'm-
That's it. 'cause
I'm kidding.
Thank you.
I got one more thing I want to say. One of the reasons here too, this whole thing is I mentioned how quick things can boot. It's your standard Docker images, just blow it up across all the data center. But what this allows you to do is to get more into a DevOps arena too, and a dynamic, much more dynamic system. We're not talking minutes to bring stuff up and down. We're talking seconds. It just brings that a lot tighter. But it's a DevOps opportunity also, because what it does is if you run Docker images, you've pushed all the real packaging problems out to the developers to make sure their stuff runs in this environment. And therefore you don't have the operational problems you have in VMware. Did I get the right stupid JVM on all my machines? That all goes away because you're running Docker images. That makes sense? Does to the developer. Okay.
There are all kinds of other problems though with that. So the VMs say, I'm going to take a box and make micro boxes out of it.
Right.
This says I'm going to take a box and be part of a mega box.
Well,
It's the
it's still,
opposite.
but
The
it's
problem
still.
is you have shared resources. Like, okay, I've got this giant computer. What about TCP ports? You know,
Well,
like if I'm gonna
it
run
does, this
my app-
doesn't change any of that problem.
Sure it does. If you're one box, and I want to run syslog
It's
on
not-
514,
it's not-
514's gone
No, it's
for
not.
everybody.
No.
514 is gone for everybody.
Well, no, the way I'm picturing it, I'm obviously there's a
Yeah, if
solution to it. There are all kinds. Going the other way, it doesn't have any of these problems. If I take a big box and make smaller boxes,
Yeah, but
that
you don't, just like in VMware with Mesos, you do not build a 1,000 core machine. You do not build a Docker image, a Docker job, I don't even know the right terms for Docker, that consumes 73 cores when you got 2 core machines. You build microservices, Hadoop and everything runs on this already. It's just spread. It looks like when you ask Hadoop, I need 17 2-core machines. You get 17 2-core machines spread across whatever resources there are.
Right. So if you had one machine and 514 is gone for that one machine, what's the issue?
It's more an effective utilization.
So
Because
just trying to picture
no problem.
how it. So you said you give it a job and it runs the job, okay?
Right.
And
Well-
it's one computer, and it can run a whole bunch of jobs.
It's-
One computer says, I've got maybe an IP
No, you've got-
address.
you've
I
got-
know I've got 100 NICs now, or 200 NICs.
No, you don't have one IP address. You really don't have one computer at the core level. You've
So
got
I'm over literalizing that
yes,
concept.
yes,
Because that, when I started picturing that, I started running all of these
yep. No,
very
you've got
problematic.
grouped a resource that looks like 1,000 nodes up at the Mesos level, but it's really 1,000. I mean, it's
So
a
when
sum
I
of
give it
1,000
job and
nodes.
request a resource, it really does create, in essence, a virtual computer, not just a job. So there's a 514
Right.
in my job, and there's a 514 in another job, but it might not actually be 514. I'd have to somehow link them together. But that's a little different. So it isn't a
It isn't a single system
it isn't a big
image.
computer, because when you said that, that's why I started saying that. I don't
Mainframe.
know, you can use it for that with anything, unless you had this job that just needed like computing the biggest prime number.
No, computing weather.
There you
for-
go. It's just run.
you know, computing the weather models, the NOAA weather models
Yeah.
or something. The CFD problems there.
So
Hey,
that's
before
how
everybody
that
leaves,
works.
right, so this has
Well,
been
I
a...
got to give away my book too, so don't.
Yeah, okay, so before everybody leaves, this has been a wonderful two-day event, right? I would like to thank the organizers. There's a lot of effort has gone in, right? So Dave, thank you, and your set of people who are behind us. We all appreciated what has gone
I've got
behind.